So in this video, we will discuss about edge crack versus central crack. So we have seen the Griffith criterion for the crack propagation. So let us draw the cracks here. So here, let us draw the central crack versus the edge crack. Here, the crack here is 2A. Let this crack size is 2A. And here, this crack size here is A. Is A, and here the central crack size is 2A. It's almost twice. It is twice. So, what's the difference? See, by intuition, you know that the edge crack is the fracture stress in edge crack is much more than that in a central crack of equal size. That is, but if you quantify it, you can see that a edge crack of length A has the same fracture stress as the same fracture stress as central crack of length 2A of length 2A. That means fracture stress sigma F is equal to 2E gamma by pi A whole raised to half. Here A is equal to half crack length for A central crack for A central crack, and this here A is equal to full crack length for edge crack for edge crack. Now we will discuss about stress concentration. So it is stress concentration. So again we will draw a body with a crack here. That is, so this is 2A, and here the applied stress is sigma A. Here the applied stress is sigma A, and here this is the crack tip radius, rho. Okay. See, as you move towards tip, okay, you can see that the stress. So if you draw like this, so this is the crack tip, crack tip, and this is distance from crack tip. So this is sigma A. So you can see that as I move from the crack tip towards the center, you can see that the stress is coming down. That means at the crack tip, you can see that at the crack tip, you have the maximum stress. That is called stress concentration. So stress is concentrated at the crack tip. So how to quantify it? That is sigma max. So what will be the maximum stress? That will be at the crack tip. So that is will be equal to sigma A 1 plus sigma A is the stress at the center of the crack. Sigma A by 2 into A by rho. Rho is the crack tip radius. Right? Okay, that is 2 into A by rho. So you can see that. See, this is why earlier airplanes had square windows. Now it is changed to this kind of an oval shape to avoid the stress concentration. Because in its sharp corners, you can see that here the rho is very small. Okay, rho is very small compared to this oval version, right? So when the rho is very small, you can see that if rho is very low, the sigma max will increase very much. So stress concentration increases, and this can lead to fracture. So to avoid that, we are avoiding all these kind of sharp corners and notches.